Hi there. This is interesting because I have my external webcam and I'm making a screenshot of the feed towards the PC. This is GreenCheck NL. I'm talking about basically building solar systems, heliostats, solar concentrators, and doing the electronics for that. And today I have a very nice new thing which I developed with a lot of help of Michel Blom. And that is a way to very accurately determine the position of your mirror using a magnetic rotary encoder. And because I want to show you the electronics and I want to show you the data stream, I use screen capture with an external webcam. I think it's pretty funny that it's all possible on a tiny notebook. But it doesn't even run Windows full featured, so there's lots of functionality there for free. Open source. This is also open source. It's more or less open design. So the idea is to my main concern is basically the transition to renewable energies, because the fossil fuel energies are dwindling and they're basically reserved for industry, which makes a lot of people suffer. But the people that are selling the carbon and selling the nuclear fuel and are controlling the system have no interest in enabling renewables, because that will reduce the cash flow. They become important. Basically, they are obsolete that you really don't want to have, and people are suffering because that how to get say across or through the financial crisis, a lot of that. And basically the way to sort is to build renewable energy sources, so you don't need external energy. You can use and manufacture whatever you want with your own power and your own machines. Anyway, to do that you need you can first of all generate a lot of thermal energy with solar light, or you can concentrate sunlight on solar panels, or you can move solar panels towards the sun, so their output is much more, about 30% increase maximum you can achieve, I believe. And to do that you have to know the position very accurately, especially for solar thermal applications where you use mirrors to concentrate light, or where you use Fresnel lenses to concentrate light. And I've talked about a project called the Glass Revolution, where you actually attempt to melt glass. If you like the whole idea of that, you should check out the website and read a little bit, and of course subscribe to the website. A monthly subscription of €1. I need only 3,000 subscribers, and I'm working on to get those. And you get a free personal QR code, contact code, so when people scan it with their smartphone they get your contact details. That's an added bonus. But to talk about this system, what you see on the screen is a data stream coming from a microcontroller. This one on the left, it is a big microchip, big microcontroller, and it's needed in this project because it is fast by itself. I believe it runs on 8 megahertz. I think I have to check that. At least it runs fast enough to interpret the output of this device here, the magnetic rotary encoder of Austrian Systems. It's a 10-bit encoder. You can also get 12-bit encoders. That means that if you have a circle of 360 degrees and you have 4,096 positions, you get about 10 different positions per degree, which is very precise. It means that if you have, and it's quite a constant output, so it's not, let's say, jittery and noisy like the analog output. It's much more stable, and that's why I'm after this. It means that if you have a mirror and you want to point it at something, then you can go farther away with the mirror. And as long as you read the position out and you have a motor system that keeps the mirror relatively stable and oriented, you can go, let's say, to about 60 meters, I believe, and still hit a target which is not very big. Let's say a tiny target with your mirror, so that you can concentrate light on that target. Otherwise you would have, let's say, very jittery reflections to that target, and you would not be able to concentrate much light at one time, because the wind would move the mirrors in all kinds of directions and you would have a very weak concentration. In this setup we use an inverter as well. That's this chip. It's a 20-cent TTL device, which is necessary because we put out the serial data through the black wire here to the PC directly, to the serial port, with basically nothing between. Sometimes you can put in a 180 ohm resistor. So this is, if you combine it with existing PCs, it's a quite low cost setup, because the chip costs about, I think, €3 or something like that. The AS would cost a little bit more, about 10 euros or 12 euros. And then you need some components and a wire, so you're for two position sensors you're done for about, well, let's make a nice printed circuit board with it, you're done for about 25 euros. Then you have the data stream you see below on the screen, and I can demonstrate how it works. I have a magnet here which is now trying to escape, but it's basically stuck to the bottom of this bolt, and I put it above the magnetic rotary encoder here, and then you can see on the screen that the S1 value will start to have a value. It's 957.831. It's very variable because you have to put the magnet in a certain distance, and there's, let's say, the variation is quite sensitive. Also because it can be used as a switch and as a kind of another indication of something happening, so you can make a button that you can turn and push at the same time. But now you can see it's position 861, 868, 912. Well, I'm moving it a lot. If I turn it to the left, you can see the value goes down, 761, 743. Turn a little bit more, 605. Now in a practical application you have to make sure that the magnet is connected to an axle that is stable and doesn't jitter or anything, and then the sensor is connected a little bit further away within specifications of the let's say the data sheet where it has to be, and then you can simply read out the position. So this is what we've been working on, and of course I have to put this in a actual rig. I have two of these rotary encoders, and I have a chip that allows you to read out the data from both. The output is now text, which can be interpreted by the PC by Python script, and let's say another step that still needs to be made is that the chip can also output data that is very easy to interpret by PIC-XA microcontrollers. These microcontrollers can have serial input from any port, and they simply need a leader character and then some bytes. If you do that, then this is the sensing part, which has to be high frequency anyway, because the AS5040 or the AS5045 outputs data at a very high rate. You have a sensing part in your device, and you have a controlling part in your device, and even a PIC Micro 08M2, which is the tiniest one, can control the motors in response to this data as long as you hook it up to the serial output of a computer. So that's where we are right now, and let's say next step is to show you how it works in practice in an actual rig, and how you then know if this is hooked up to the internet. You can see online what's happening with your device. You can control it from online, and I think that's nice, very interactive, and then hopefully, well, we can get some. And this is for this open design. So if anybody's interested in building this, then let me know. I'm looking for about 3,000 subscribers to my website. And if you go to the website, you can go to the left and subscribe. It costs about €1 per month, as long as PayPal is operational anyway. and that would keep me going doing this. Anybody that wants to invest in building rigs, I have the glass revolution, and I still need money for doing that. I use this technology to orient mirrors and lenses and melt sand, in order to make it a construction material in dry and hot places, so that you don't need carbon to construct. You don't need carbon to construct renewable power installations, and that's the ideal situation, because now we're still, let's say, dependent on the carbon credit economy to allow us to move to renewables, and that economy simply doesn't want us to move to renewables. It wants us to basically do less and less with the remaining fuel, because if they don't, they lose their power, and they don't want to do that. Nobody ever wants. But anyway, I'm going to have another coffee, and I hope this is helpful and interesting. Thanks for listening.